Hello, everyone. Recently, you completed an assignment focused on secondary data analysis. So, I wanted to share with you an example of how I have used secondary data analysis in some of my research. Uh, Within the past year or two, I have been working on an innovation focused on potentially slowing the spread of communicable disease, specifically the flu. And so, in preparing for that, and in looking at background and significance information, I ran into some research that's been done uh, linking weather and flu. So I just found this interesting, and I wanted to explore it a little bit more. So I worked with several meteorologists and an epidemiologist, as well as some others, to explore weather data and influenza reports. Now, I started small with this, just seeing if it was even possible to do. And fortunately, we found out it was possible. But I started small, looking at the area in which I live. So I live in East Central Mississippi in Starkville, and just wanted to take a look at what we have going on here, just because I'm familiar with the geography and just the area in general. So I'm going to share this presentation. This was actually a presentation that was presented last fall at the University of Alabama in Huntsville. There was a conference that was funded by Google, the NIH. I think NOAA may have been a part of this, but they were looking at the Tempo database, which is a new type of database that collects satellite data related to air pollution in certain areas. So this was similar in that it is looking at environmental factors that have an impact on your health. So in this presentation, or for this work in general, I have collaborated with an epidemiologist from the Mississippi State Department of Health, two meteorologists from the National Weather Service in Jackson, Mississippi. I also worked with a scientist, a researcher at CAPS, which is part of the University of Alabama's Center for Advanced Public Safety. They have some folks over there that are working on weather messaging, really more specifically related to like tornado, severe weather threat type messaging. But nevertheless, they're familiar and work well with the National Weather Service folks, and then also a data analytics expert from Mississippi State University. So again, I'm just going to go through this briefly, but what I want to show you is I want to actually show you part of the data set that we worked with and how this data set came about, and then how the analysis was approached, and then ultimately the findings. So I don't want to read everything for you here, but I know you all know flu is community-based. It's a community-based virus, and it affects so many people worldwide, right? These are some statistics related to influenza. Again, I don't think this is anything that you're not familiar with, with your background as nurses. And we also know there's a financial impact that the flu has on the economy. Now, this is sort of where we get into the research that I found that sort of inspired me to go this route. So there is some research that suggests, links, relationships between cold temperatures, low indoor humidity, minimal sun exposure, and influenza epidemics. Now, looking further at that and looking more closely, we can see in that literature that there's also places in the world that don't experience a seasonal type climate. So maybe those closer to the equator, where they don't have this variation in temperature like we do in our part of the world or other parts of the world, and they don't have this variation in humidity levels. They have minimal variation in sun exposure, but they also experience seasonal flu epidemics. So what is it? what is it about this relationship? How is this working? So the purpose of this retrospective correlational pilot study was to explore the relationship between historical weekly weather data, which included temperature, humidity, and barometric pressure, compared to weekly influenza-like illness reports over a 4-year period. Now, I will go ahead and share with you that this weather data was extremely granular, okay? We're talking about weather sensors that are strategically placed in different parts of the district where we were looking, and throughout the state. The National Weather Service does this everywhere, right? And these sensors are collecting data sometimes every 15 minutes, sometimes every 20 minutes. And then you have on the opposite end of that, completely polar opposite to that, is this influenza-like illness report, which is coming from the state health department. This influenza-like illness report is simply a rate, okay? And I saw that a number of you all had also experienced this type of data in, what you had collected. It was a rate or it was a percentage. It was not necessarily an N. It was not necessarily a data point or a set of data points that you could, begin to analyze. So this again is an example of how we've taken something that was very, or it's certainly in the form, it's just in the form of a rate. And another part of that is this rate is really based on, in Mississippi, it's not required to report flu-like illnesses to the state health department. So these are folks that are calling in, they've made it part of their workflow. They're going to call the state health department once a week and tell them what they had in regard to, ILI, and share that with the health department. So this is not even an actual N like we're seeing with these COVID cases. This is just simply a rate that is being reported and shared through the state health department. And we're trying to merge that with a very granular data set of weather data that has been collected so continuously for 24-hour periods at a time, and then beyond that, 365 days a year. So very, very different type of data sets, and we're trying to merge them to see if we can look at correlations and begin to make sense of the relationships that exist. So this was the data set, I'm sorry, the data source, that light green shaded area there at District 4. I live in Starkville, and that's the district we're in according to the public health department or the state health department in Mississippi. So I looked at only ILI, so influenza-like illness rates reported in that district alone. Then we looked at weather data that was coming from this district. So these are the only sensors in that district. They're at mostly, there are a couple airports there, and then there are a couple that are out in rural areas. Nevertheless, these are, continuously sensing weather-related information, collecting it, storing it on a database, and unless there's an issue with the sensor, this is going on constantly. So I will share with you now what we started to look at with this data. So this is, you can see across the bottom here, these tabs, we had 2014, 2015, 2016, 2017, and 2018. We ended up in the end only using 4 years in the analysis, but this is, you can see the dates on here, and large data set, okay? Daily, every 15 to 20 minutes in some cases. And what we ended up doing was a lot of averaging of the 4 sensors, the data that was collected those times for the week. And then we merged that eventually with the flu rate percentages, okay? which were collected manually. And here is what the flu-like reports or the influenza reports look like. This is just an example of one coming out of the Mississippi State Department of Health website, and what they look like. So I'm down here looking for District 4. What is the rate for that week, week 10, week 11? They report them 2 weeks at a time. So the next week, for example, this was week 11. You would see week 11 and week 12. And they can change. These numbers can change. So you have to be really careful when you're collecting them. And that is because this is not syndromic surveillance. This is people calling in to the health department, reporting ILI symptoms. And so again, these ILI reports are reports of people coming in with these types of symptoms, not necessarily a positive flu test. So that's how it's reported in the state of Mississippi. Every state is going to vary. But this is the data that eventually feeds into the CDC flu reports and things that they have on their website. But nevertheless, this is where that data that is coming from this column came from, okay? So this is just 1 year as an example to show you how this all sort of came together. So then, if you can imagine, we start charting this out a bit. Let's see if I can show you some examples here. Yeah, and we start seeing, where the relationships are through the analysis. I'll go back to the presentation here to show you. We were able to collect some descriptive statistics across the years, and our results we found first, and I don't think this is going to be anything that surprises anyone. There's a inverse relationship between the flu rates and the temperature, and this certainly goes hand in hand with flu season. So when we see these temperatures drop, we see this ILI rate percentage go up. Okay, so you can see that relationship, that inverse relationship, certainly exists there. So this was a way to validate that, what we see. We also saw some relationships with relative humidity. This is outside humidity. This doesn't have anything to do with the, the humidity that's climate controlled. And then we also looked at dew points. There was a lag time that was calculated through a regression analysis, and that lag time was 2 weeks. So we saw basically, when we saw certain conditions in the weather pattern, so a drop in temperature, cloud cover, where it was mostly cloudy or more cloudy, then usually 2 weeks later we could see a spike, if you will, in influenza-like illness reports. And again, this is within the district, within the state of Mississippi. So it was just very interesting to see, number one, that we could actually, we got a typo there. We could see this, we could work with these data sets, and then beyond that, to actually see the relationships was rather interesting. So there were limitations with this. Obviously, the lack of granular data at the health department level. And again, I know this is what some of you all were probably dealing with the data sets that you looked at, the things that you were finding. While this information is very, very helpful in terms of background, I mean, I could tell you through the analysis here, how these flu rate percentages are trending. I still need, more information to begin to look at relationships, correlations, etc. Again, another limitation was that it's the influenza-like illness reports are only shared on a volunteer basis. There's no requirement. But in talking with the epidemiologist, and it was a very good thing to have her on this project because she could explain to me and help me understand how this data was collected, which has implications on how it is used and how we can analyze it or begin to merge it with this other to analyze it. But in talking with her, these rates are very much a reflection of what is going on, in reality with the flu, what we see. The data from the health department is estimated and used only to represent the magnitude of the distribution of flu within the state. So again, not an exact report of flu statewide, and remember, it's not necessarily even a positive flu test. So you just never want to overstate what you're doing in an analysis like this. We were limited to 4 years because, again, we were just really trying to see this was pilot. We were trying to see if this was even possible. And then we were also lacking weather stations, really. However, again, in speaking with the meteorologists, and it was a good thing that they were involved as well because they helped us understand how this data was collected and the relationship among these 4 weather stations. We can tell you very confidently that the weather is not going to change that dramatically in the district. We might have a storm roll in one part of a county and not affect the other, and if you're from the South, you can completely understand that in spring, summer, when we have these pop-up storms and the cooling effect and things that go along with that, the pressure dropping, etc. We're still not going to see that drastic of differences. And so those averages that we're getting, that we're working with after we're combining this data to create a weekly average, it's a fair thing to do. So in what we found was obviously this seasonality with flu remains unclear. We need to continue to research in this area. And again, so we can begin to sort of disentangle this public health issue we deal with yearly. And as far as the implications, including nursing in something like this, we know nurses have always been a part of health promotion. We promote flu vaccine campaigns, specifically in this case. We encourage people to wash their hands, to do things that are going to help spread infectious disease. And of course, that's going on right now with COVID as well. Anything that is infectious disease, we want to do what we can to encourage others to mitigate, right? We also know that in exploring the relationship between weather and influenza through syndromic surveillance, we can begin to illuminate more relationships that signal a probability of an outbreak. And through that, through things like this analysis, the syndromic surveillance, we can begin to encourage nursing to be part of the weather enterprise, facilitating more innovative ways of preparing the public for impending outbreaks, and also preparing our clinical settings, right? So if we know that the weather conditions in an area are looking like, okay, this is sort of the recipe, if you will, we see when we see a spike after this, then we can inform people so they're prepared. Certainly future research, we need to do a lot more. But I just wanted to show you, again, this was all sort of an example, just informative information for you all to see how we were able to take this data, 2 very different data sets, and through with secondary data analysis, begin to make sense of it. So I'm happy to answer any questions about this. This is certainly a work in progress, and I will tell you that this work is actually under review right now at a Advances for Nursing Science, but then we're also working to create a case study paper that is focused on showing or illustrating that we can sort of graph this out and begin to, through data visualization, see relationships and begin to interpret, right? So again, for the purposes of being able to prepare and inform others. So please feel free to contact me with any questions that you may have about this, or the secondary data analysis assignment that you completed. Certainly appreciate all your hard work and exploration of the topics of your choice. So contact me with any questions.